So for this lesson, we're going to go over the power rule. So for the power rule, if you have a variable raised to a power, to take the derivative of that function, you take the power and bring it down as a coefficient out in front of the variable, and then subtract 1 from that power. So for example, if we have the function x to the third power, what we do is we'll bring down that power as a coefficient in front of x. So we have a 3x then, and then we subtract 1 from that power. So the power is going to be 2 now. So our f prime of x is going to be 3x to the second power. Because again, it's x to the third power. We move the 3 as a coefficient in front of x. So then we have 3x, and then we have to subtract 1 from that power. So we do 3 minus 1, which gives us 2. So our result's going to be 3x squared. And then we can do the same thing if we have a function that already has a coefficient out in front of it. So for example, if we have the function 8x to the third power, we do the same thing for the derivative, but we just keep the 8 out in front. And like before, we're going to subtract 1 from the power, and then we'll bring down the original power. So we have to bring down the 3 and subtract 1 from the power. But we just keep the 8 out in front because it's a constant. So we'll just write 8 and then the result of the derivative of x to the third. So the derivative of x to the third is going to be 3x squared, just like before. So we have 8 times 3x squared. So it's going to give us 24x squared for the derivative. So now what about something more complicated here? So say we have the function 6x to the fourth minus 5x squared plus 9x minus 7. So we could just look at each term here individually and then take its derivative, just like we did in the last lesson. So let's look at the 6x to the fourth power first. So we take the derivative of 6x to the fourth, and this is very similar to taking the derivative of 8x to the third. So this 6 here just hangs out in front, and then I'll take the derivative of x to the fourth. So what we do is we bring the 4 down as a coefficient. So I have 4x, and then the power gets reduced by 1, so the 4 becomes a 3. So I have 4x to the third power. And then let's look at the minus 5x squared term. So the minus 5 is going to hang out in front. And then I take the derivative of x squared. So I bring down the 2, which gives me 2x, and the power reduces to 1. So we have 2x to the first power. And that's just going to be 2x then, because x raised to the first power is just x. And now I have the plus 9x. So in the last lesson, we already discussed that if we have a linear function like 9x, the derivative of that is just going to be 9. It's going to be the coefficient out in front of x. So we're going to have a plus 9 here. And then we have minus 7 for the last term. And we know that the derivative of a constant is going to be 0. So derivative of negative 7 is 0. So we have a plus 0 here. And now we can just simplify this. So we'll do 6 times 4x to the third, which is 24x to the third. And then 5 times 2x, which is minus 10x. And then we have a plus 9 here. So our final answer for this derivative is going to be 24x cubed minus 10x plus 9.